So before starting this video, let me tell you that if you have any doubt regarding this problem, you can ping me up on Instagram. Even you can join my Discord server. I will provide both the links in the comment section. I'll pin them. So in this video, I'm going to discuss the gold rush problem which occurred in today's Code Forces challenge. So the problem is very simple. So you're given two numbers. This is the M and this is N. So what is basically given, that you're given M number of gold plates, and you can divide it into two parts such that one part is having twice number of gold plates than the other part. That is basically, let's say if you have n number of gold plates, so you can divide it into two parts. One will be n by 3 and the other will be 2n by 3, right? Because one part will be containing twice of that of the other part. So by using this relation, so you know this, so you have to check if it is possible to make this into this, okay, at any point of time. Like it is like a binary tree. So if as it goes downward, so if any of the element is equal to this, so we have to print a yes, else you have to print a no. For this 6, so 6 can be divided into n by 3 and 2n by 3, that is 2 and 4, right? And so see, 4 is present over here, so we printed yes over here. For 9 can be divided into 3 and 6, and 6 can be further divided into 2 and 4. So 4 is again present over here, so it's an yes. For 4, it cannot be divided, okay. So 18 can be divided. So this goes on, okay. So you have to check for everyone. So now the basic approach of the problem is, you can't use all the possible cases to determine it because it will give you a TLE, okay. So the naive approach is not applicable over here. That is a recursive approach. This is not applicable because this is going to give you a time limit error. So what you are going to do, you have to find, as if you know about the recurrence relation thing, so it is basically n is going to divide it into n by 3, 2n by 3, right? N by 3 is going to be divided into n by 1 by 3 into n by 3, that is n by 3 squared and 2n by 3 squared, right? And this is going to be divided into 2n by 3 squared and 2 squared n by 3 squared, right? And again this is going to be divided, so these goes on dividing, okay. So this thing becomes 2 to the power 3 n 3 to the power 3, and this thing becomes n by 3 to the power 3, right? And all them between are something which lies in between this range. So you know one thing, that if m is possible, okay, so I think I reversed it, okay, I made this as n and I made this as m. I hope that is very much clear to you. So I have to find that whether at any position any of this element can be m or not. So what we can say about this, that all the elements over here are in the form 2 to the power x by 3 to the power y n, okay, is equal to m. That is m by n is equal to 2 to the power x by 3 to the y. Very much clear. But remember one thing, this x is always lesser than equal to y for any case, because if it goes on further dividing, it becomes 2 to the power 4 by 3 to the power 4. It never becomes 2 to the power 5 by 3 to the power 4, something like that, okay. So x is always lesser than equal to y. So what you can do, you can divide m and n, okay, and after you're done with the division, like you can find the GCD and reduce it to the shortest form. And once you have reduced it to the shortest form, you can check for like if it can be represented in the form 2 to the power x by 3 to the power y or not. How you are going to do, so let's say a number p. How can we determine whether p is in the form of 2 to the power x or not? You have to divide p until it is divisible by, till it is divisible by 2. You have to divide p by 2, and after done, if p is equal to 1, so we can say that it is in the form 2 to the power x. Similarly, if we want to check if q is in the form 3 to the power y or not, so we can divide q, and q by is equal to 3, and if q is equal to 1, so we can say that it is in the form of 3 to the power y. Remember one thing, you have to also check for this y and x thing, okay. So what you are going to do basically, so like let me give you a just sample of the code, okay. So m is So let's say this is n, like let's go into the direct problem. So this is m and this is n. So basically the thing is that n should be in the form 2 to the power x by 3 to the power y m, where x is x is lesser than equal to y. So what you can do, so n by m is in this form, so find the GCD of n and m and divide both of them with it. So we reduce it to the lowest form and then check if n can be represented in the form of 2 to the power x and m can be represented in the 2 to the power y form, and remember to check x is lesser than equal to y condition. So these are, like, let me write it. So first step, GCD and divide m and n. Second step, check if n is equal to 2 to the power x, that is it is in the form of 2 to the power x, and m is equal to 3 to the power y. Okay, and the third case is check if x is lesser than equal to y. If all of them satisfy, if 2 and 3 satisfies, it's an yes. If it doesn't satisfy, it's a no. Okay, so very simple problem. So I hope it is clear. Like for this you can check that 9 by 4, the GCD of 9 and 4 is 1. So 9 can be represented as 3 squared and 4 can be represented as 2 squared. So it's a yes. For 6 and 4, the GCD is 2. So we have to divide 6 with 2, it becomes 3, and 4 with 2, it becomes 2. 3 is basically 3 to the power 1 and 2 is basically 2 to the power 1. So it's an yes. For this 4 and 2, 4 cannot be represented as 3 to the power something. So it is a no. 18 and 27, you can divide it. Like first of all, you have to find the GCD. So the GCD will be 9. So this becomes 9 2s and 9 3s, right? So it becomes 9 2s and 9 3s, and it cannot be like it cannot happen in that form, that it is this has to be in 2 to the power something form and this has to be in 3 to the power something form. So it's a no. So I hope this is clear. So this is the basic logic behind this code. So that's it from my side. Thank you.